In this section, I want to show you the anatomy of a Starknet smart contract without going into too many details. We will delve into the details in future sections of this course. A smart contract is defined as a module annotated with the Starknet contract attribute. An attribute is a type of macro that modifies our code during compilation to enhance its capabilities. This type of behavior of having code that modifies code is called metaprogramming. In this particular case, the Starknet contract attribute tells the compiler to turn a regular module into a smart contract. The internal state of a smart contract is defined by a struct named storage, annotated with the storage attribute. The struct has to be named storage. Any other name would make the compiler fail. The public interface of a smart contract is defined using a trait with a generic type. When implemented, the generic type is replaced by the concrete type of the smart contract storage, and it can have any name. In this example, the generic type is called tContractState, but it could have been just T. It's a matter of taste. Each method within the trait that defines the public interface expects to be passed the smart contract state. A method can receive the state as a reference using the keyword ref if it plans to change the internal state during its execution. On the other hand, a method can receive the state as a read-only version of the smart contract state if it only plans to read from it without modifying it. A read-only version of a custom type is known as a snapshot and is defined by an ampersand placed before the type. In this case, the set method gets a reference to tContractState because it will modify the internal storage by setting a new value to it. The get method, on the other hand, only reads the variable from storage and returns it to the user. This is why it gets only a snapshot of the internal state and not a reference. Finally, to define the logic of each method, you have to create an implementation annotated with the attribute ABI embed v0. This attribute tells the compiler that the methods are public and can be called by any user or smart contract. The v0 is just a way to future-proof how selectors are created without breaking older code. Currently, you have to be careful to not have two traits with the same method name, as it will cause a collision and the compiler to fail. In the future, selectors could be derived in a collision-resistant way by using a new version of the attribute like v1 or v2. In the body of each method, you can see how to interact with the storage of the smart contract by using self, accessing the storage field you want to use, and then the method write or read, depending on if you want to modify the state or only read from it. The purpose of this section is only to give you an idea of how a Starknet smart contract looks like. In future sessions, we will learn in more detail how to create a smart contract using Cairo.